Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into the fascinating concept of slicing the fourth, exploring the complexities of higher dimensions. Let's start with the basics. What even is a dimension? It's simply a direction, right?
Exactly. Think of a person confined to a line, one-dimensional. They can only move left or right. Add a ladder, and suddenly they can move up and down too. Two dimensions. We represent their position with X and Y coordinates. But how does this relate to a fourth dimension?
That's where it gets really interesting. Imagine a 2D being, let's call him Oliver, observing our 3D world. He only sees the cross-section of objects intersecting his 2D plane. A finger passing through his plane appears as a circle, a cube as a square. This is analogous to us trying to understand a 4D hypercube.
So a 4D hypercube, a tesseract, is like a cube made of 8 cubes, just as a cube is made of 6 squares, and a square of 4 lines. It's a beautiful pattern. But how do we visualize it?
We can't directly perceive it, but we can understand it through its cross-sections. If a hypercube moves through our 3D space, we'd see a series of changing 3D shapes, starting as a point, growing into a cube, becoming more complex, and then shrinking back to a point. The math gets involved, using rotation matrices to describe the hypercube's orientation.
Right, the rotation matrices are crucial. They allow us to rotate objects in 3D space, but the article also discusses extrinsic rotations, where the axes of rotation remain fixed. This is important because matrix multiplication isn't commutative. The order matters.
Precisely. And the math gets even more intricate when we consider a rotated hypercube. The cross-section we observe isn't a simple cube anymore. It becomes a more complex shape, like an irregular hexagon. The article even provides the equations to describe this shape.
Wow, that's a lot of math. But the article cleverly uses this complex math to illustrate a simple point. Even though we can't directly see the fourth dimension, we can infer its existence through the changing cross-sections we observe.
Exactly. And it's not just about cross-sections. The article also touches upon projections, another way to represent higher dimensions in our 3D space. It's a more straightforward method, simply truncating the fourth coordinate to visualize the 4D object.
So the key takeaway is that while we can't directly experience the fourth dimension, we can use mathematical tools and analogies to understand its properties and how it might manifest in our 3D world. It's a mind-bending concept, but the article makes it surprisingly accessible.
Absolutely. It's a testament to the power of mathematics to help us grasp concepts beyond our immediate sensory experience. And that's all the time we have for today's episode of Tech Bytes and News. Thanks for joining us, and we'll see you next time. Goodbye.
Bye-bye.